Okay, so the goal of today is to bring some logs out of Kubernetes and get them into Coralogix. And we're going to use the Open Telemetry Collector for this. Open Telemetry is a wonderful initiative providing a shared language across many different observability platforms that everybody agrees to. It's a wonderful open specification and standard. Simply means that we can all start to share metrics, logs, traces, and bring them all into one place and really get some cross-data, cross-functional analysis of all this observability data that we typically silo off ourselves. At Coralogix, we're big supporters of this, both in open source contributions, but also we integrate fully with this. So we integrate logs, metrics, and traces. Today we're going to focus on logs, and there are going to be some other videos on metrics and traces. So before we pull out any logs or start to install anything, we should just inspect the cluster that we've got. So we've got a terminal here. If I just get the pods and I do it in all namespaces, we can see that I've got Jenkins that's restarted a few times, an instance of my app. My app is just a Docker image that I found on Docker Hub. Just prints out random log lines at different severities. It's like 10 lines of bash and it's got over 1 million downloads. So it just shows it doesn't need to be a complicated application to become popular. The rest of the pods are just kubesystem, the internals of Kubernetes. So, and you can see behind it as well, by the way, that I have an empty Coralogix account, no data whatsoever. So we'll need to begin by installing the Open Telemetry Collector. I'm going to use Helm for this because I find Helm and Kubernetes work quite well together. But you can use, there's a bunch of different ways to install the collector. Just pick the one that works for you. So step one for me is just to list the repositories I've got. I can see the Open Telemetry repository I've already added to my list. So if I do Helm search repo, Open Telemetry, we can see that I have the collector, the demo, and the operator. The operator is super cool. We'll definitely do some videos of that in the future. For now, we'll focus on the collector. So the way to install the collector is the way to install anything with Helm. Is Helm install, I will call it my Open Telemetry. I'll tie it with some scripts I've got later. And the name of the chart. So it's Helm install, the name of the Helm installation, and then the name of the chart. Helm, the Open Telemetry chart also requires you to set something when you install it. So you can use the set switch for that mode. So you can install this Helm chart in two different ways, either as a deployment or as a daemon set. As a deployment, it will just be a collection of pods. You bring information to it, and it'll forward it on and process it in all the ways that it does. The other option is as a daemon set, where it will work on different. It'll run on each node. Running on each node is far more convenient for us because we're collecting logs. So I'm just gonna kick that off, and with a bit of a look, there we go. So that's run. So if I do kubectl, I'll get pods now. We can see that I have one ready pod. Lovely. So at this stage, we need to integrate this with Coralogix. So how do we do that? Really straightforward. We should start by looking at the documentation. So you can look on the Coralogix site, but we also have documentation right here in the Open Telemetry repository. So you go to the Open Telemetry organization and then the Open Telemetry Collector contrib repository. In that is a folder called Exporter, and in there is Coralogix Exporter. You'll see in the Exporter folder there's a whole bunch of different features and functionality that work for you there, but and you see lots and lots of different solutions. We're right here, Coralogix Exporter, so we go into here and you can see some example configuration. This is basically what we're going to do. We're just going to get rid of the traces and metrics part and just keep the logs part, but you can see how simple it is to add traces and metrics if you want. So to add traces and metrics, what we'll do is I have already put together some functionality in here. So this config is very similar to what you can see in the website. I've just simplified it a little bit, and it just saves you having to watch me mess around and indent YAML files. So from the top, I've added some extra stuff. Kubernetes attributes, so this will add some Kubernetes metadata to all of our logs. Things like restart count, namespace, pod name, container name, and so on. Useful contextual information, really important to get that in actually. And logs collection will actually enable the Open Telemetry Collector to actually start pulling logs from the containers automatically. This is an important one. Include collector logs. This stops the sort of infinite loop of the collector produces logs and then it reads its own logs and sends them to Coralogix, and then it produces a log to say, hey, I just sent some logs, and it reads that log and it gets in a bit of an infinite loop. Then we have the configuration for Coralogix. So we set the logs endpoint to the otellogs.coralogix.com/443. This will vary depending on your region, so make sure you cross-reference that. We have a table in the website. And then we have your private key, which we'll show you how to get in a minute. Application name and subsystem name, if you're not aware of these, they are methods for correlating your data across logs, metrics, and traces. So everything has an application name and a subsystem name. And finally, the timeout, which is 30 seconds. Obviously, it's a decent idea to set timeouts to make sure that things like thread locks don't happen. You're not consuming resources you don't need to. You'll also see this mode daemon sets. This means when we upgrade this, we won't have to actually manually set we won't actually have to manually set the command and the switch. So this is always nice. So how do we do this? Well, first I need to get a hold of my private key. So the way to do that is to go to your Coralogix UI, and you'll see when you've got no data, you've got these lovely start sending data buttons. So I'll just click on the logs one, and that will load the tutorials page. In the top right of the tutorials page, you can see the private key. So you copy that and you just paste it. I'll obviously do this off screen so you don't see my private key. And then we'll bring in the terminal again. So I'm in the same folder as that. I've written this script upgrade Otel just to make my life easier. It is a one-line command, one-line script that upgrades the Open Telemetry, my Open Telemetry release with this Helm chart as before. But this time we have this -f values.yaml, and that will install using the values file. So I can just run upgrade Otel. Cool, so now that's running. I can do get pods, and we can see that already the collector agent is kicked up. Now, if I run K9, which is my favorite Kubernetes tool, strongly recommended if you use Kubernetes a lot, I can see my collector agent here, and I can see that it is already exporting some stuff, which is nice. It's very, very cool. So if I can escape out of that, that means that logs are now moving from our cluster all the way to our application. And you can see the kind of logs that are being generated. So if we look at the my app one, for example, so we'll open K9s again, and I'll pick this guy here, you can see that this thing is just generating some simple logs. Nothing particularly sophisticated, but just nice and easy, just demo logs that we can use. So when you want to validate that logs are arriving at Coralogix, the very best way to do it, in my opinion, is to use the LiveTail feature. So what makes Coralogix different is that we have this fundamental architectural difference called Streamer. Streamer is all about capturing data quickly, analyzing it, processing it, triggering alerts, updating metrics, updating monitoring dashboards, and then at the very end, indexing and storing. And we analyze in stream. So the point is that rather than all these expensive storage operations where you constantly throw things around and you're constantly storing information in all sorts of different places and transforming it in many different ways, which is very expensive, high overhead, but also very complex and very difficult to scale. Instead of doing all of that, you simply ingest, and we use a combination of Kubernetes and Kafka streams, and that together has made the streamer architecture that makes for a very, very fast experience. So if I hit start now, you can see LiveTail. LiveTail tells you the second the logs are hitting the system. It's very, very low latency stuff. So you can see the logs are flowing now, which is really great. And actually, if I go to my Explore page, I can see a bunch of logs. So before there was nothing, and now we've got a bunch of logs. And we can even see the application subsystem settings that we put in that configuration file, which is really, really cool. So it's just a really quick, easy example of how you can pull logs out of Open Telemetry and get them straight away into Coralogix. Now, since we have such interesting data, it'd be a shame not to analyze this a little bit. So there's one or two things that I've noticed, the restart count and the container name. So we can use these to produce quite a powerful metric of restarts per container, right? The way we do this is with a really great Coralogix feature called logs to metrics. So let's take a note of where this data is. So resource, attributes, and then K8's namespace name, K8's container restart count. So we go to our logs to metric UI, we see no metrics defined. We'll call it something sensible, restart count metric. We don't need a query because we have selected our app and our subsystem, which is super handy. So now we can pick a severity. I'll pick all severities. Everything coming from this cluster will have this data, so I'm interested in that. The metrics field I'm going to call count, I suppose. Seems reasonable. And we said it was like k8.restart count or container.restart count. I think it was. There you go. Now I want to group. So what I can do is group by container, and I can do k8.container name. So what that's going to do for me is what that's going to do for me is it's going to capture a bunch of this really interesting data, and it's going to put it into a place. It's going to put it into an actual metric form, which is really, really important because it means that the data itself, we could actually get rid of the logs if we wanted to. This is one of the things that it says really clearly at the top of the logs to metrics UI. So while this takes a minute to start calculating, the thing with logs to metrics that's really powerful is that you can ingest a bunch of logs, crunch them down into the data you actually need them for, and then get rid of the logs. So this translates into sometimes even up to a 60% cost saving, which is significant. And it's basically all about getting you to do the most with the data that you've got and not hang on to the data you don't need. Because the thing with observability data, especially the thing with logs, is that they are very verbose, and half the time you don't need like 90% of them. So features like this enable you to really dig in to the data you want, drop everything else, and only pay for the data that you really want to make use of. So it's not just about data ingested, it's about really being efficient with what you've got. And this is what Coralogix is the best at by a mile. It's all about making it really, really easy for you to do the right thing with your data. So logs to metrics actually takes a minute to work. So we're going to have a quick cut, and then afterwards we'll come back and we'll have some metrics to work with. So this usually takes roughly 3 or 4 minutes. So rather than just sitting around and talking for 3 or 4 minutes, we can do a little jazz. So hold tight. Okay, so everything looks good now. We can see that the DataMap screen is here. So this is what I really, really wanted to show you. So logs to metrics has captured the logs, it's pulled out that restart count, and it's made it available as if it was any other metric, which is really, really powerful, because what this really enables you to do is obviously drop all that old log data that you don't necessarily need and keep the stuff that's driving your visualizations, keep the stuff that really, really means stuff to you. And that translates into an obvious cost saving, a significant cost saving, up to 60% sometimes. So what we can do is we can add a group, we can choose our metrics, we have count there, it's very convenient. And we can generate groups. So when you generate groups, what you do is what the DataMap UI automatically does is it will automatically say, okay, here's a label that we've got, container. It's the only label on the metric. So it will group by that, which is perfect for us. So what you can do then is you can set a status. So we'll set a status of maximum because we're interested in the highest number that there's been. And we'll say, okay, 0 is green, 1 is a bit worrying, 2 is a big concern, and 3 is a problem. And if we apply that now, we'll see that config reload is red. And this took us what, 2 minutes to do? And we already have this really great UI that shows us the restart counts of all of our containers. With the power of logs to metrics, you can generate any metrics you like from previously untapped wealth of data that you could sync into. So this is just a really great example of how Coralogix really sort of raises the bar. So you can see here that this metric is kicked in straight at 4. And we've got some evidence here to indicate that we're well above the 3. That's a problem. If we compare that to my application, right down here at 0, behaving itself very, very well. So this is just a really great example of how you can use Coralogix to tap into data, analyze it, crunch it, drop what you don't need, and keep the stuff that really drives your insights, really lowers that mean time to recovery, and generally makes for a much more effective operational team. Thank you.